Oh, there was a button that said go live? Why would that be there? Two out. Oh no, wrong one. Oh, that's 2120. Look at that. All right. All right, that was on me. There was a button that said go live, but I was streaming. Let's get rid of. I can only listen to myself once. I can't do the echo. Pop out chat. There we go. I try to block it so that you only see one of me. No, I want normal playback. 720. All right, cool. Now we can get into. All right, so if you still need the link to like main course website, you can scan this QR code. Let me move it up. Does anyone need to take a picture of QR? And then the reason for streaming all this is one, so that there is a stream, so you can log in on YouTube streams for each of these lecture days. And then the other part is that you can always rewind, like especially if we're doing like coding exercises. A lot of times I'm like tap, 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 done, execute. And you might have missed something along the way. So you can always rewind or go back to a previous lecture, try to figure out like, how did he do that? Why is it's still giving me some kind of syntax error. Like A range is ARANGE, not ARRANGE in NumPy. But, all right, now we can get into, now we're making a little bit of progress, right? All right, so far in Husky CT, this first link will bring you back to that course website that I just had the link up for. So if you didn't get it, you can always get it from Husky CT. And then our course syllabus is again going back into that 3255. I feel like light works better on a light mode, better than dark mode. All right, so I've been talking and troubleshooting a lot so far. Yeah, all right, we're working. So now, question for you. Why do you think you should be in this class? I know it's required. Like, someone told you you have to be here. But if you could kind of step out of that, like, I need to check this box because I have lots of boxes and this is one of many boxes and this is my box and it is I will. But if you step out of that mindset of like just cranking through all these courses, why you could use Python, MATLAB, C++, like Java. There's all sorts of programming languages. They're all kind of mix and match the same, but like this idea of computational thinking, like why would you solve a problem with a computer rather than just like you can look up tables, interpolate stuff, you can create equations for things, simplify them down. Why do it with a computer? What do you think? Oh, you want to answer? I was going to ask you to write it down, but yeah, go for it. Efficiency? Do you think it's more efficient? So I'm going to hand out like index cards, just like write down something, share But yeah, efficiency. Is it more efficient to use a computer for this kind of stuff? So far people mention like speed and efficiency for like computational thinking. But if I want to know F equals ma, if I want to know total force to accelerate something, I know it's 1 kilogram, I know I want to move it 1 g. Do I need a computer to figure out how much force I need? Not really, right? Just 1 kilogram times 1 g, so it's 9.81 newtons. So there's a lot of cases where it's faster to just not use it, like not get a computer involved. So why, but then there's gotta be cases where that's not the case, right? So where's the trade-off? Like when does it become faster or more efficient or something like that? Done? Can't standardize? What would standardize mean? Okay. Would that help? Where would that help? Okay. Yeah. Like, so what would be like a standard problem that computer does? Yeah, how it solves that. Okay, that solves. Yeah, like turning it into a process. Yeah, certain process. Okay.
Well, just one example I can think of is like if you're trying to get a simulation like gravity, you get 1 or 2 bodies, it's not even possible to do it.
Yeah, sometimes it's just totally intractable, right? Yeah, yeah. So even the 3-body problem, there is no like closed form equation that you can say that this is my function. Yeah. Okay. All right. So this is at least like I just took a quick cross section of not a representative part of the room, but part of the room. So someone said like scaling problems. Was anyone thinking about like scaling, like the idea of scaling up? Usually I guess we would think of scaling up rather than like I did this calculation. Let me see how to scale it down. Like do less. I don't know. I think scaling up was the main idea. Yeah.
Something that involves too much data.
So data problems. Okay. So maybe like data analysis. So there's have you heard the idea of like big data problems? That's like Google-sized problems where you've got millions of users and all of those users have like 15 to 20 gigabytes of data. So now you've got like petabytes of data that you're trying to process and go through. Usually engineers don't have, at least like mechanical engineers, usually we don't have big data problems, but that doesn't mean we don't have data problems. Like the steam tables are a prime example of a data problem where we know the answer, but it's just hard to get there because it's all buried in tables. So we spend a year to 2 years learning how to read tables and find answers. That's an example of like a data problem that we would have. And it's a sizable amount of data, but you can scale it all down to like maybe a megabyte worth of information. So like data analysis, complex problems. Was anyone thinking about like complex? And I think it kind of ties into these kind of tied in together a little bit to me. Like unsolvable or complex problems. Was anyone thinking about something like that? What were you thinking?
I was thinking like something with at least more than 1 degree of freedom.
Okay, yeah, like multi-degree of freedom problems. Yeah, because those can sometimes there are like exact answers for 4, 5, 6 degree of freedom problems, but it just takes, it's a lot of like doing the same thing over and over, and then you get to one closed form solution and you're like, it's perfect, and it's like the collection of 7 sines and 7 cosines. Like this is really hard to work with. So sometimes it's nice to just pipe all that into like a bunch of numbers. So computers are great with dealing with just straight up 1.76893, but it's not good at dealing with like this function is a cosine function. It's good at passing information to and in and out of a cosine function. Like what is the cosine of this string of number? This like not a string of numbers, but like a whole bunch of numbers. Yeah. And then so complex, I asked like, did they mean like complex like root -1 problems? And they're like, I guess so, sure. What do you think? Have you been dealing with like complex algebra and that? Do you think computer is the way to solve the z-plane problems, the imaginary real components, and sometimes it makes things, it's like when a computer gives me like imaginary numbers, it's like, oh my god, I just it gives me a 0 imaginary plus some amount real. I'm like, I just want the real part. Like, why are you giving me? Sometimes it complicates things. No pun intended, or pun intended, however we want to go. And then standardized solutions. This one was kind of interesting to me, of like standardizing. So what would that mean if you're like standardizing a solution? And why would a computer be good at that? Or like, what would a computer help you with there?
Think of it as storing a solution or storing an algorithm essentially to say, hey, I can now plug in new numbers to repeat the same type of calculation.
Yeah. So if you have a process that you've kind of, and even if it's something that you've worked out on paper, like you know how each variable kind of connects to the other, you can turn that into either a function or a little library, like some kind of tool where now you can say like, all right, this is still going to be the same object, but I want to change the arm length from 1.3 centimeters to like 0.9 centimeters. Rerun the analysis and see what the outputs are. There's also kind of a deeper thing to this that's part of like this class of like, if you can turn your like problem into a standard problem, like, so that some examples would be like, if you can take a set of equations and turn it into a linear algebra problem, you're golden. There's decades, there's probably 100 years worth of stuff that people have solved, and in the last like 50 years, there's tons and tons of libraries that will do almost any solution that is a linear algebra solution. So if you can reform those like sets of static equilibrium equations or finite element kind of like what are the stresses and strain, what are the displacements and the forces on all of these nodes, if you can turn that into just like this matrix times that vector equals something else, then you've got a ton of ways that you can solve that where it's a drop-in replacement. And like the magic of Python and MATLAB too, but the magic of Python is that you import solutions. You're not creating solutions. So we'll import NumPy over and over through this semester, import matplotlib to visualize things. So there's all these like extra things. So like turning things into linear algebra, turning them into initial value problems. So taking like an unsolvable problem, like a 3-body problem, where you have three masses that are all attracted to each other, whether it's electrostatic or gravitational forces, there's no closed form general solution for where they're going to end up. You can't just say like, it's a cosine wave. It's like, well, sometimes, other times, no. So that kind of answer, if you can set it up as an initial value problem, then you can use built-in integrators. You import, here we'll build some, I'll show you like some of the internals of how integrations work, but you can also just say, hey Python, give me the solve IVP function and let me choose what kind of integration I want to use. Oh, sorry, I missed one. And then automation. Did anyone think about like computers and automation? Well, one person did. Well, at least 1 or 2 people did, but was anyone else thinking about like how you can automate things with Python or just the computer in general? Not so much. Automation is one of the reasons that I think Python is a great, if you're gonna only learn one language, Python is a great language to learn because it's not easy. I'm not gonna say any of this is easy. All of this is hard, but it can make your life easier. Kind of like, I don't know, like going to the gym is hard, but it does make your life better, or riding a bike or running. All these things are like difficult things that take skill, and it takes, like, you have to work at it. But at the end of the day, you're more fulfilled, you have more energy. Learning to code is kind of like that. Like, if you're putting in the work and you recognize like how you can problem solve this way, it doesn't make anything easier, but it makes a lot of things easier to deal with, and kind of like changes the way you approach problems, and also kind of standardizing how you see problems and how you frame them. So like one example for automation, your crazy professor like wants you to email an update for your senior design project every Friday afternoon. And it's like, oh my God, how am I going to remember that? You could set up a Python script that always creates a canned email, like a canned response every Friday afternoon at a given time. And then it pops up into your like, hey, can you approve this for sending to your professor every Friday? You know, like that would be an automation of something that is not necessarily a computational problem. Like it's not, we don't need like physics and lots of other things, but it's a great way, it's a great like computational thinking problem about like, all right, every 7 days, create this email, maybe ask ChatGPT to fill it in a little differently every week, like grab a software development kit from ChatGPT to like fill in some details here and there, and then you plug in the finer details of like, these are the top 3 things that we did this week for senior design. But that was kind of what I was thinking. Cool. So, and it's funny, the first times that I asked about like, why are you in this class, the answer was always just like, either learn MATLAB or learn Python, depending on what we were approaching. It's like, well, to do what? And it's like, well, to do all this like cool stuff, like getting some like skills out of this, not just a general sort of like, yes, I'm a master of Python because I spent 14 weeks using Python. It's like, well, for what? What'd you build? What'd you do? How did it work? Okay, so speaking of like Python, kind of do's and don'ts of the course, we still have time. So let's say let's do an example, right? ChatGPT. I don't need to log in, right? Do you know what the FizzBuzz interview question is? Has anyone heard of this? I heard someone, you like put your head down. Do you already know what it is?
No, I've heard it before though.
Okay, all right. So did anyone like fall asleep when I said FizzBuzz? Or like roll their, I just saw your eyes roll back, so I was like, oh, he must know. Does anyone know what FizzBuzz is? No? So it's an interview exercise that if you're like, I'm good at coding, then one of the things they might ask you is, okay, well then do a FizzBuzz, like live code a FizzBuzz example. And the idea is that you want your program to output the numbers 1, 2, but when you get to 3, you want it to output fizz. So instead of 3, it prints fizz. When you get to, and then you print a 4, and when you get to 5, it prints out buzz. And if it's divisible by both 3 and 5, like 15, then you write out FizzBuzz, maybe like an exclamation point. So the process is like trying to get you to think through how to use if statements, how to use a for loop, all those kind of like core computational thinking problems. So we kind of understand where we're going. So one thing I could do is like, since it's the 2020s and I'm doing a remote interview, I could just say, hey, ChatGPT, I need a FizzBuzz solution written in Python. And then it's even going to tell me like what is FizzBuzz. So even that little exercise of me mansplaining FizzBuzz, it'll show me this result. Oh, cool. So it did like, rather than having an I%3 and I%5, it just simplified it to I%15, because then it kind of covers both of them. Kind of cool. And then it even shows me like, okay, this is how it's approaching it. So my question for you is, let's say this is homework. Homework number 1 is just a FizzBuzz solution. And I copy the code and paste that into my Jupyter notebook. Thumbs up, like totally fine, or thumbs down, no, not okay. What do you think? Thumbs up, thumbs down, totally fine, some totally fine. Okay. Some halfways. So in the work that I've done so far, like I gave it an instruction and then it gave me an output. So why, even if you want to play devil's advocate, or if you do think that it's okay, either way, I'm not trying to call you out and be like, gotcha. It's more of just, I want to understand your perspective, like your ethics of academic integrity, especially as we have like new tools and resources here. So why is it okay to just take this output and claim it as my own property now? Why would that be okay? Yeah.
Well, I feel like in a couple of years, like everyone's gonna be using stuff like this to solve small problems.
Okay.
Like it's gonna be
like a slippery slope argument of like, well, everybody's doing it anyway. Yeah. Okay. Yeah. So part of it is like, it's a tool and everybody's using it. So if I'm not on board, I'm just getting left behind. Would be like one argument.
I feel like as long as you learn why my ChatGPT wrote down what it did, that's fine for it.
Okay.
If you can understand what thinking ChatGPT did to get to that solution.
Yeah. So if you're like following the logic and kind of thinking through what it's doing, so maybe that would be okay. Does anyone want to say anything else?
This summer, I had to use Python a little bit and process and do it, and I was like, I'm not really. They told me to just use ChatGPT.
Yeah. Okay. So one thing that is, in terms of like, can I own this piece? So there was like all those arguments are totally fine of like why you would use this and why you would like put that into, because our homework is kind of like our production, right? Like we're taking this, we like processed it, like, okay, it seems like it works, let me just dump it into my submission and move on. So in terms of like, can I own this piece of code? The answer is a straight up no. Like I could never like copyright this piece of code because it was generated by AI. Do you know why that is? This one's really weird. It has to, yeah.
Doesn't have a human author.
There's no human author. Yep. Yeah, there's no human author. Sorry?
Does it make it a common place or something?
It is under like Creative Commons license, and part of that is that the result of this code, like this output, is the result of probably, going back to a big data problem, like 10 to 100 million different pieces of code that all kind of were built to create this one thing. So if you were trying to reference like, oh, I got this from these references, your reference page would be like, yeah, dozens of pages of like size 10 font. Does anyone know why you can't own AI generated material? Yeah.
Because it's trained off other people's copyright stuff?
Yeah, it's trained off of, sometimes it's copyrighted, sometimes it's like Creative Commons. Yeah. So that's part of it. But the other part is that there was someone, this was back in like 2010s, someone was taking pictures of macaques, of monkeys, and he had some pictures, and then one of the monkeys took the camera and took a selfie. So this person was like making money off of this monkey selfie, but then people published it on Wikimedia Commons, and he tried to argue like, hey, you can't do that, that's my picture. Their argument was, no, the monkey took the picture, the monkey is the author of this picture. And so then it went all the way into the court, like this Slater versus Naruto problem, and the court ruled like, no, the monkey, in order for you to have co-authorship, the monkey needs authorship, so the monkey needs to make money off of this, but the monkey cannot be an author, so therefore no one is an author. So it has to be Creative Commons license. And that's what people reference when someone says like, hey, I made this AI artwork. They're like, nope, Slater versus Naruto, a monkey took a selfie, so now you can't own AI art. Yeah, the monkey selfie, yeah. Yeah, if we look up like monkey selfie, this is him. Yeah. So this is, and it's not to say like, it's bad, but it's a great thought experiment of like, it went to court, yeah. This went all the way to, I thought it was. But anyway, that's the official U.S. copyright statement, is that if it's generated by AI, it's not yours. And there's a lot of other ethical reasons for that, like you're profiting, like if you were to take that and own it, then you'd be profiting off of lots of other people's work that fed into it. But in terms of like your own schoolwork, you should be able to copyright your own homework assignment, right? Like it's something that you have put in lots of work into, like you're thinking about it critically, like it is something that if you wanted at the end of your UConn career, you should be able to just like staple together all your work and say, this is my like learning to engineer at UConn, and you should be able to publish that. And most people do. Like if you get a master's degree or a PhD, you can staple together your work and publish it as your own thesis of work. All right, so we've got like 2 minutes left. Let's say I want to So let's say I want to take this code and I do want to like create my own version of it, like something that I can say is my own intellectual property. One way to start is like copy and paste it, make sure that it works. Like that's the first step, is make sure that it works before you do anything with it. Like don't submit it if it's not even gonna work. So here at least I know it's working. So I'm getting 1, 2 fizz, 4 buzz, 6 is fizz again. So it seems like it's working. And then let's go down to 15. I do get fizz buzz. So I could start like changing this output. Like I want to make it say fizz buzz with an exclamation point, right? So that's a minor change. It doesn't really do much. I could also start changing variable names and start making it my own. So like now instead of like I'm going to replace these I's with counter, like something that makes sense to you. This is and also like it's working the way that it is, but I could take this whole thing and turn it into a function, right? So I could take that function from ChatGPT, turn it from, so whenever you just have like stuff happening, it's called a script. And if you put it inside of this DEF statement, now it's a function. So I'm taking some of my own knowledge and kind of transforming what this thing is doing. Really, I need like a return statement, but I'll just like return 0 for no real reason. Oh, and I misspelled FizzBuzz. It would help to spell it right? So now I'm starting to have like something that it's still doing the exact same thing that it started with, but I copy pasted, now I'm improving. And that's really the difference to me, whether it's like working with someone else, whether you're getting it from a textbook or ChatGPT, like copy, paste, debug, then start improving it. Even if the improvements are like making it more readable or making it more your own. But it's a huge difference as to whether or not you can claim this as your own work. But anyway, cool, thanks a lot. Thanks for suffering through our first YouTube stream debugging. See you on Wednesday.